All right, so this section is on parametric equations, and if you did not first view the Khan Academy video on the intro to parametric equations, I want you to stop, go back and watch that 11-minute video, and then this one we're just going to recap a little bit of definition of what parametric equations are and do one example. So I want you to watch that intro first so that you have an idea of what we're even talking about as we go through this example. So like he mentioned on Khan Academy, we're introducing this third variable that we talk about x and y in terms of, and we call that a parameter. So right now, up until now, we've only graphed and looked at functions and things in terms of x's and y's, and now we're introducing a third parameter, which is an independent variable. In our case, it's typically going to be time. So it's an independent variable on which other variables rely. And the great thing about parametric equations, or this third parameter, is that, like you saw in Khan video, instead of just looking at things in terms of x's and y's, so we looked at y in terms of x, or we can look at x in terms of y. Now we can look at both x and y in terms of time or some other parameter, but in our case it'll typically be time, and we'll say, okay, well, how high was something at a specific time? Or how long did it take for something to get this far in terms of x? So it introduces the ability to talk about more real-world applications. Like, that's why Khan kept talking about physics, because it helps explain the physical world around us so much better, and specifically projectile motion, which are things, objects in motion that have been projected. So we'll get to that in a second. So the definition of a parametric equation is a set of equations in which in each equation a different variable, so in each equation a different variable, and in our case our variables are x's and y's, is expressed in terms of some parameter. Expressed in terms of the same parameter. So x is going to be expressed in terms of time. Y is going to be expressed in terms of time. Specifically, we are going to use parametric equations to model projectile motion. So, and Khan mentioned in that video, assuming that a projectile is unhindered by forces such as wind, its horizontal and vertical distances x and y are given by these two sets of equations. So let me just talk about these equations very briefly. Do not panic. You will not need to memorize these. I will give them to you, and really we're just going to use this set of equations. This set of equations would be useful if you look at it. So if I want to know x in terms of times, meaning horizontal distance, then I would need the horizontal velocity. That's what v stands for. Time, that's what t is, and d naught, or d sub 0, represents a initial horizontal distance. We will not be doing problems with specific horizontal velocity and specific vertical velocity. That's what the v sub x and v sub y stand for. If you look at these set of equations, it's overall directional velocity, so it's not broken down into horizontal or vertical. It just depends on whatever angle whatever direction the object was projected in. So don't worry about memorizing these again. We are going to stick with this set of equations. So all you need to know is that x represents the horizontal distance, t is time, v is velocity, theta represents the angle at which the projectile was put into motion. So like if you're throwing a ball, theta would be at what angle was that ball released from your hand with respect to the ground. T is time, d naught means initial horizontal distance, and then y of t is vertical distance in terms of time. So our third parameter is time in both of these. This part of the equation right here, negative 1/2 gt squared, that represents the force of gravity. So obviously we need to pull in and make account for gravity when we're talking about vertical distance of an object, because we are subject to gravity. V again is velocity, sine theta. So theta again is the angle at which the object was projected. And h naught is initial height or initial vertical distance. So we're going to use these in this example so you can see how we can use this third parameter of time. All right, so Ziggy Duffer hits a golf ball on the ground with a velocity of 150 feet per second. So we've got a golfer standing on the ground. His ball starts here. He hits the ball at 150 feet per second, making an angle, a launch angle of 9% to the ground. So not 9%, 9 degrees. So that 9 degrees is our theta, and that's the angle at which our object was put into motion with the ground. So he hits this ball at a 9-degree angle with the ground, and it's got a velocity of 150 feet per second. So we have two questions that we're going to answer using parametric equations. How long is the ball in the air? How long? That answer is going to be some amount of time, which is why this parametric equation idea is going to help us, because we have that third parameter. How long is the ball in the air? So I want you to think about what that means. How long is the ball in the air means what is time when the ball hits the ground. So what is that time, or how long does it take until the ball is back on the ground? Meaning y would equal 0. Think about what that means. So the ball, y equals 0 initially. Change colors. The ball is hit off the ground. A certain amount of time passes. We want to know how much time until that ball, y equals 0 again, back on the ground. So the first step that we need to do is write our equations. Write equations. So again, we're going to be using these equations, and let's break them down piece by piece as we write them. So the first thing is we write x of t equals, so we're right here, x in terms of time, horizontal distance in terms of time, equals v, which is the initial velocity, 150 feet per second, as stated in our problem. So 150 times the cosine of theta, and theta is that 9 degrees, so cosine 9 degrees, all of that times t, plus d naught, or d sub 0, which is initial horizontal distance, but we're just going to assume that this is starting kind of like at the origin, or at 0, 0. So that's just going to be plus 0 for horizontal distance. The y parametric equation, y in terms of t, is negative 1/2 g. Now that g is the force of gravity, and gravity, if you remember from the con video, He wasn't working in terms of meters. We are in feet. We are given velocity in feet per second, and gravity in feet is 32 feet per second. And you don't need to memorize that. I can tell you if you need it. Again, in meters is 9.8. So that'd be negative 1/2 times 32, and then t squared. Again, I'm just copying straight from our equations up here in the box, plus initial velocity, v, which is 150, times the sine of theta, theta is 9 degrees, times t, plus h naught, or h sub 0, which is initial height of the object. But this golf ball is starting off on the ground. So a golfer has the golf ball on the ground and hits the ball, so the initial height is 0. So these are our parametric equations. Now we're just going to clean them up and simplify them because we can actually compute 150 cosine 9. We can simplify negative 1/2 times 32, and we can compute 150 sine of 9 degrees. So our actual parametric equations simplified are x of t equals 150 times the cosine of 9. So you'd want to compute that. And make sure you're in degrees since we're given our angle theta in degrees. 150 times the cosine of 9 is, let's see, 148.15. And then I have t. That's it for x of t, because the rest of it is just plus 0. Y of t would be negative 16t squared plus 150 sine of 9, and that's 23.47. We'll do 23.5t. So those are our parametric equations that we're going to use for this. Now back to part A, which is asking how long is the ball in the air? And we essentially want to know what is the value of time, t, when our y value goes back to 0. So basically, we have our equation for y, and we want to know when that is 0. So we want to solve for t when y of t, our vertical distance or our height, equals 0. So all we're doing is saying, okay, when does negative 16t squared plus 23.5t equals 0? So we solve for t. How do we solve for t here? Well, we've got a t in both terms, so let's factor one out. So t times negative 16t plus 23.5 equals 0. Now I have two factors that multiply to equal 0, so we should know that we can set each of those equal to 0. So t equals 0, basically that means we've solved this solution equals 0, our vertical height equals 0 when time equals 0. Well, yeah, that should make sense because our golf ball starts at a time of 0 with a height of 0. That's not the solution we're looking for. This is going to give us the solution we're interested in. Negative 16t plus 23.5 equals 0. Or negative 16t equals negative 23.5. And then we divide by negative 16. And we get the solution for time. T equals approximately 1.47 seconds. So in about 1.47 seconds, that ball is back on the ground. So over here, it takes about 1.47 seconds for that ball to hit the ground. So we've just used the parametric equation y of t to solve for time when the ball hits the ground. The next question will pull from what we just did. So this was part A, again, which was just asking how long is the ball in the air. Solve for t when y equals 0. Part B is saying How far will the ball travel in the air? How far has it gone? Meaning, what is that x value all the way over here at when that ball finally hits the ground? Well, if we know that the ball is in the air for 1.47 seconds, then we can find the horizontal distance just by plugging in that total time that it's traveling in the air, 1.47, into our horizontal equation, x of t, because now we know the total amount of time it's in the air. So for part B, all we have to do is plug total time into our equation x of t. So we're going to take x of t, this, and plug it into 148.15 times 1.47. So we just calculate that, plug it in, 1.47, and we get 217.8. So we know that the ball traveled from here to here 217.8 feet, and we know that it took 1.47 seconds to do that. Notice we never talked about x in terms of y or y in terms of x. We talked about both horizontal and vertical distance in terms of time. So that's the purpose of parametric equations. So just to recap, the first step is just write your equations and then answer any questions you've been given based on what they're asking. So we'll stop there and finish up this section of notes in class together.